Hello, everyone, and a very good afternoon to everyone present here. I'm your host, Khushi Mudgal, and I welcome you all to today's TechGig webinar on the changing face of artificial intelligence. It's an absolute pleasure to have all of you join us today. To facilitate this session, folks, please join me in welcoming our distinguished speaker for today's session, Mr. AmitKumar Shrivastava, Global Fujitsu Distinguished Engineer at Fujitsu. He's recognized for his leadership in AI. He has experience with machine learning and deep learning algorithms, including computer vision, generative AI, agentic AI, cloud native AI, and responsible AI. His work spans retail, manufacturing, public and government sector, and healthcare, combining technical depth with domain understanding. He has played a key advisory role in India's national program on AI, contributing to the development of Gen AI standards, national occupational standards, micro-credentials, and AI-ready curricula. He also actively supports the ecosystem as a mentor and advisor to academic institutions, startups, industry associations, and global technology councils. Honored among the 25 AI pioneers, 40 path breaking AI leaders, and top 20 AI influencers, he's also a LinkedIn top voice, Forbes Council member, and a frequent speaker at Premier Forums. It's such a pleasure having you, Amit, here with me today.
Thank you so much, Khushi, and thanks for the introduction. Good afternoon to all, and thank you for taking the time to be here. Uh, so AI has been everywhere over the last few years. We were observing it, and now we have seen impressive demos, rapid adoption, and a lot of excitement in this area. Many of us, I'm sure that here they are building, deploying, and governing system day by day. So this session is intentionally not another overview of models, tools, or architecture. Instead, I want to talk about something more fundamental. What is actually changing about the role of AI in our system and in our lives? We are going to begin with the language model that generates text and code, or we have begin with the language model that generates text and code, and possibly we are seeing this euphoria in last 2 or 3 years. We are now moving towards world models that learn how the real world behaves, and increasingly we are entering an era where AI system act on our behalf, sometimes physically and sometimes autonomously. And now this shift from intelligence to agency, it's subtle but it is profound. It changes how decisions are made, how responsibilities are assigned, and how trust is established between humans and machines. Over the next 1 hour or maybe 35 minutes so, I am going to basically walk you through these connected changes that together explain why the face of AI today looks very different from what it did even a couple of years ago. My goal is not to tell you that AI is powerful. I think you all know it. My goal is here to help us think clearly about what happens when understanding, decision making, and action slowly being shifted to from humans to machine. So let me start. Now, we are seeing this conversation, like why this conversation feels different today compared to even a few years ago. For a long time, we talked about AI primarily as a prediction engine. It predicted demand, it predicted risk, it predicted outcomes. Then gradually, AI moved closer to decision making. It started recommending actions. It started talking about options. It started advising humans. What has changed recently is that AI is no longer stopping here. Increasingly, AI systems are acting. Now, if you see this, prediction, decision, and action, what it actually says that today AI triggers workflows, it reallocates resources, moderates content, approves transactions, and in some cases, negotiate on our behalf, even executes on our behalf. So this is a very different role now. It means AI is not here for only supporting decisions, but it is becoming part of our decision chain itself. Once a system acts, questions of responsibility and control immediately change. Now, the second point related to narrow models, foundation models, and then agents is nothing but an architectural change. We started with narrow models that solved very specific problems. Those who are into machine learning, they know they used to train a model for a specific task. Now we are moving towards, or we have moved to foundation models that can generalize across the task. Now again we are going back to some sort of domain specific models, but right now we are not discussing on that. But now all of these models or those models are increasingly wrapped inside agents. And when we talk about agents, we are not only talking about large language models, we are also talking about domain specific models, or maybe smaller models, that system that can plan, execute, observe outcomes and adapt. So at this point, the model is no longer the system, the agent is the system. And agents behave very differently from tools. Tools wait and agent acts. Now if you see the third point related to software to socio technical infrastructure, this shift is perhaps the most important, I feel. AI is more than now the software that team deploy. It is becoming part of the infrastructure that shapes how human work, how decisions are made, and how organization functions. That means failure. If you see failure, these are not now just technical failures. They are increasingly become the organization failure if we talk about failure from an AI perspective, sometimes even societal ones, right? So when we talk about AI today, we are not really talking about accuracy improvements or maybe the latency improvements kind of thing. We are talking about a shift in where agency lives. And once agencies start moving from humans to machine, the questions we need to ask change completely, right? This brings me to the first visible sign of the shift, the way we interact with AI itself. Now, let us look at what is happening to something very familiar to all of us, the prompt, the one we talk, all the time. So, if I have to start, thinking from a prompting perspective, possibly 2 years back, everybody was going crazy over prompt, and that was very natural because everybody wanted to, interact with AI. They wanted to have some, understanding of the tool and also want to execute something or maybe tune something for whatever they are asking, like the Q&A kind of thing, or maybe understand some domain or some document and etc etc. But over the last years or last possibly 1 year, I would say, we spent a lot of time talking about prompt because when I say we are talking about prompt, it does not mean that you are just randomly talking about prompt. You are actually trying it within your enterprise or within your projects as well. So when we say prompt, we basically are talking about prompt engineering, better prompts, longer prompts, smarter prompts. And prompts were important for sure. They still are important. But the deeper change is happening right now is the centrality of the prompt is basically now slowing or maybe slowly fading. Now traditionally, AI system waited for us to be explicit. We told them exactly what to do. We described the task. We provided the instruction, and that interaction model assures that humans always know what they want and they can clearly express it. Now modern AI systems are being designed around a different assumption. Instead of waiting for explicit command, they increasingly try to infer intent. Now what changed recently is not only about the better models. What changed is the integration of perception, memory, and action into a single loop. AI system now see images, hear audio, observe behavior, remember context and connect these signals in real time. If you see the multimodal AI, that is vision, audio, and context, so AI is not only processing text, it sees what we look at, it hears how we speak, it observes how we behave over time. Instead of asking, what did the user type? The system start asking, what is the user trying to do, right? And when AI observes behavior, it does not wait for instruction in the traditional sense. It notices patterns, as we understand, where we hesitate, what we repeat, what we ignore, and what we respond to. From this, it forms a hypothesis about our intent. Now, this is often described as better user experience, and sometimes it is, for sure. But there is a deeper consequence that is easy to miss. Prompts are control mechanism. we all understand. They force humans to be explicit. They create a moment of intention and consent. As AI moves towards inferred intent, those explicit checkpoints become design choices, not defaults, right? And imagine an AI system that detects stress in your voice and face expression during a conversation. Without you asking, it escalates the issue, schedules a follow up, or trigger a workflow. In many cases, that feels helpful. But the important question is not whether it works. The important question is who decided that this action should be taken. Now, to be clear, this is not an absolute shift. For complex tasks like coding, maybe legal writing, or maybe detailed design, etc., explicit control still needs to be there. It still matters, but and in fact, it will continue to matter as well. But the direction is clear. In simple terms, if we are moving from telling machines what to do to machines guessing what we want, this may feel like a small interface change, but the change in how intent is expressed are often the earliest signals of much larger shift in agency. And that brings us to the next question. If AI systems are increasingly acting based on inferred intent, we need to ask something deeper. What happens when those same system also starts learning primarily from themselves? Now, before we get into that, I request Khushi to introduce a poll so that you know we understand something from your side as well. Khushi, if you can just open the poll.
Yes, Amit, I'm sharing.
Yeah.
So the first poll question is that what is meant by model collapse in the context of generative AI and large language models? And the options are a failure caused by insufficient GPU memory during large-scale training or inference. Option B, the degradation of model quality over time when models are repeatedly trained on data generated by earlier models. Option C, a sudden loss of model performance due to adversarial attacks or prompt injection. And option D, a reduction in model accuracy caused by aggressive quantization or pruning techniques. All of you are requested to vote and let us know what you think is the right option. And of course, we'll be revealing the correct option towards the end of the poll. And you all are also requested to put your questions in the Q&A tab so that we can take those questions towards the end of the session. We'll be closing the poll in a few more seconds. So all of those who are left, you can let us know what do you think is the correct option so that we can have a better understanding of the answer. All right. So we have the maximum percentage for option B, which is also the correct answer, that the degradation of model quality over time when models are repeatedly trained on data generated by earlier models. So that was a good choice by everyone who voted for option B.
So I think we are in good place. People understand. At least 50% of the audience understand what is model collapse,
Yes.
in simple language. So now let's move ahead with our next slide, where I'm going to discuss about something similar to that. That is a Habsburg AI problem and the model collapse. I think some of you might have heard about this, but let me get into this. Now, so AI is starting to infer intent and act with less explicit instruction. we understand. We need to look at the quieter but very important shift happening underneath. And the poll question was actually wanted to uh, have a sense, like at least a sense from my side to understand like what is the understanding of the audience, so that I can just try to dig deeper into this Habsburg AI problem on a very high level. And then if you have anything further to understand, because this is a very interesting problem, and I think those who understand, like the 50% of the audience, they really understand that what kind of thing is happening around the AI world with respect to model collapse and Habsburg AI problem. But yeah, this Habsburg problem, or maybe this phenomena, is very less visible right now and not much talk, but this is very important. And it has a long-term consequences for the quality of intelligence itself. So this is the Habsburg AI problem. Historically, the Habsburg dynasty collapsed because generation of rulers kept marrying within the same family. So this is the history. Over the time, diversity disappeared, strength weakened, and then fragility increased. So we are actually taking this analogy from an AI perspective now. Now, what is interesting is that something structurally similar is starting to happen with the AI systems. Until recently, AI models were mostly trained on human generated data. And you know how painful is to work on human generated data. Sometimes you have to do annotation and etc etc. You need domain expertise and a lot of manual effort. But increasingly, a significant portion of the data on the internet is now AI generated. Even if you are struggling with data, like you do not have much data, through AI you can generate a lot of data and you can utilize that data to work on. Now that means new models are starting to learn from the outputs of the older models. In other words, AI is beginning to train on itself. From a machine learning perspective, this creates a feedback loops. In research literature, this phenomena is often described as model collapse. This is what actually you have been provided an option with. And we prefer to think of it as a Habsburg AI problem because it highlights the long-term systematic risk. Instead of learning from diverse, messy, human generated distribution, models are exposed to increasingly uniform synthetic ones. Over time, those feedback loops flatten distributions, and then also variance reduces, extremes disappear, or originality declines. And if you think from a result perspective, it does not mean that it is providing you a wrong answer, or the LLMs or the model is going to provide you a wrong answer. In fact, the system may become very safe, very polite, and very consistent if you use these AI generated data many a times. But it also becomes increasingly average, fluent but shallow, correct but unoriginal, right? So let's understand from this example. Imagine a future language model trained largely on AI written blocks or AI generated documentation and AI produced summaries. It will sound confident, it will avoid mistakes, but it will struggle to surprise you, to challenge you, or introduce genuinely new perspectives, right? So this is not a short-term bug that we can patch. This is a structural risk that I'm talking about, and that accumulates over time. And it matters because we increasingly relying on AI, and this is not only for answer we are relying, we are also relying for thinking support. And what makes this particularly interesting is that the same moment when AI starts learning more from itself is also the moment when humans start relying more heavily on AI outputs. So we have a system that is becoming more self-referential and users who are becoming more dependent. That combination deserves careful attention. So to be clear, synthetic data is not inherently bad. It is useful for augmentation, simulations, and possibly and definitely for rare scenarios as well. And this risk appears when synthetic data becomes the dominant source of learning without sufficient grounding in reality. And the Habsburg AI problem does not, it is not something that you should look from a failure perspective. It also discuss about the slow degradation, and slow degradation is often harder to notice than sudden failure. That's why it's very important in AI. Now this raises an important question. If AI systems are slowly flattening their own intelligence, what is happening to us as we increasingly rely on them. I think to understand this further, I would ask Kushi to again launch one more poll so that we can understand where we stand.
Yes, Amit. So, moving forward with the next poll question. So, this goes that in the context of advanced AI systems, what is meant by a world model? And the options are a large pre trained language model trained on internet scale text and images. Option B, an internal structured representation that allows an AI system to simulate, predict, and reason about the dynamics. Option C, a symbolic rule based system used to encode human knowledge and logic. And option D, a digital twin of the physical world creating using IoT sensors and real time data. So, you all can let us know which option you think is the correct one. And accordingly, we'll let you know if the answer is right. I would like to mention again that everyone is requested to vote, and you all can also put your questions in the Q&A tab so that we can take them up towards the end of the session. All right. All of those who are still left to vote can vote. I'll be closing the poll in the next 10 seconds. All right, so we again have the 50 percentage for the correct answer, which is option B, an internal structured representation that allows an AI system to simulate, predict, and reason about the dynamics.
So I think this is, it means that the audience, they are understanding the world model as well. Like 50% of them voted correctly, 23% more inclined towards digital twin.
Yeah.
Bit different from digital twin, but yeah, I think they're pretty close to the world model that we can think of. And then others possibly, once I discuss this slide, it will make them more clear. So let me move to that. Um, a minute. Uh, Sorry, I think we introduced the poll earlier, but it's okay. I think at least we got to understand about, uh, no,
The
we got to know
understanding of
about
the
the world model. Yeah, yeah. So the poll got introduced earlier. So the slides are actually later in the presentation. But let's understand this neural atrophy and post-truth. That is something also very interesting that you will find. So now, so far we have talked about how AI systems themselves are changing, how they infer intent, and how they learn. Now I want to shift the focus because every major technology transition eventually reshape human behavior. Now, as AI system becomes more capable that we are observing, we naturally start relying on them. And in fact, we are seeing that people are relying on AI more than just answers, right? We ask them to summarize complex information. We ask them to structure arguments. We ask them to draft, region, provide recommendation, and etc. etc. And this is often described as productivity that we talk in our enterprise setup or in our day-to-day activity. And in many cases, it is genuinely it genuinely is a productivity improvement. Now, what changed in us? If I see it from that perspective, so there is a subtle shift that happens at the same time. When we repeatedly outsource synthesis and reasoning, we practice those skills less ourselves. Over time, our thinking habits change. This is I'm not talking this from a losing intelligence perspective, but it is more from a perspective of, like, how often we engage in deep independent reasoning. And that is something, we are seeing it declining, and that is not a good sign. Although we see that this is improving productivity, but at the same time, that cognitive ability is not utilized as much. So if you see from, like, let's say we have seen this pattern before as well. If I take an example from a GPS perspective, very, something that we use almost daily. When GPS become available to everybody, we reach destination faster. But many of us stopped forming mental maps. The ability did not disappear overnight. It simply stopped being exercised, right? And AI is creating a similar effect now, but for higher order thinking. Now, at the same time, AI is becoming extremely good at generating content that we know, text that sounds authoritative, audio that sounds human, video that looks authentic, and all of this can be produced at scale at very low cost. And there is no doubt about it. But this capability also introduces a serious misuse risk. We are now seeing how easily generative systems can be used to create non consensual and harmful synthetic content over targeting individuals who had no role in the system design or deployment. What is striking is, not just that this is possible, but how low the barrier has become, and how asymmetric the harm is. Creation is instant, correction is slow, and damage often persists. In fact, if you see, one of the recent example, with respect to the misuse of AI, is from Grok. Grok, people started utilizing Grok to create some, you know, uh, some bad images of especially vulnerable group like women and others. And there were a lot of hue and cry over it as well. So people are actually misusing it as well. Now, there are two things that are happening at the same time. Humans are engaging less frequently in independent reasoning, and machines are making it harder to distinguish what is real. The deepfakes thing, and something that is generated through AI, and that combination is what create post-truth environment. Now, let's understand what is post-truth. So, post-truth does not mean truth disappear. It means that traditional signals of evidence becomes unreliable. Now, video is no longer definitive proof. Audio is no longer definitive proof. Text is no longer a definitive proof. Trust shifts from content to context to identity. Now, maybe you can imagine receiving a video message from a senior leader asking for urgent actions. Possibly 10 years back, you will feel that this is, correct video, and then video alone would have settled some questions that the leader were trying to address. But now today, many of us pause not because we distrust the person, but we have no longer trust in that particular medium, or we are losing the trust in that particular medium. And why this matters for AI system? Because AI system are increasingly participating in decision making. When we say this, what we are trying to understand that when human reasoning habits weaken and evidentiary trust collapse at the same time, decision making becomes fragile. And fragile decision making is dangerous when authority is being delegated. And this is not a warning, it's an observation that we are seeing. Every powerful tool reshapes how human thinks. The question is whether we notice it early through to respond deliberately or not. Which brings us to the next shift. What happens when AI stops being just a tool and start acting on our behalf? That is also something very interesting. Now, I think you can connect with uh, that particular thing in the next slide. But also, if you see that table, there are some findings. I have basically put it from some papers and from some sources. Possibly, you can go through it later on your leisure once this slide is shared with all of you. Now, let's understand something that is making noise these days: agentic AI and delegate authority. So what we have seen till now, like we have talked about how AI system listen differently, learn differently, and how that changes human behavior. Now we comes to the most, you know, uh, most recent shift, or maybe something that people are talking about, they are trying for trying to implement something, and still not clear. If we talk from an agentic AI system, like a full agentic AI system, it's still a debatable topic, right? But if you think it from this perspective, that AI is not only working as a tool that support decision now, but it has started acting on our behalf, or people have started using to explore the option how it can act on our behalf. So when we hear the term agentic AI, it can sound abstract many times. So let's ground it. This is what I'm trying to say. So an agent is a system that can set goals, plan steps, take actions, observe outcomes, and then there is a long definition you can think from it perspective, and also adjust its behaviors as well. In other words, it does not respond only, but it is operating on your behalf. Now, why this is fundamentally different from tools? And because traditional software waits, this is not going to wait for you. It waits for input, it waits for confirmation, it waits for approval. And agent do not always wait for this thing. So that's one of the difference between the traditional software wait and the agentic part of the work, right? They act within the boundaries that we define or sometimes forget to define as well. Definitely, agentic AI is going to work, as I discussed, that they are going to work within our defined boundary, or sometimes outside the boundary if we do not define it. But fundamentally, this is the concept that is making it different from the traditional software weights, right? And we are already seeing, or maybe early version of this shift, or this kind of tool, that is basically people are exploring systems that automatically approves refunds, and then system that let's say reorder inventory, system that schedule meetings, allocate budgets, or trigger actions across platform. We are seeing these kind of changes technically on ground. Maybe not fully autonomous, but maybe multiple agents are trying to do some sort of maybe trying to do their own part, but in entirety it's still not an autonomous system completely. But what matters is that these are actually saving time for us. And each of these, or maybe each of these actually represents a small transfer of authority. Let's say if you're talking about agent A, B, C, they have a different task to execute, and they have a different transferable authority as well, and they are actually working together as a part of some orchestrator to execute our task. Maybe not fully autonomous, but still it is saving a lot of our time. And also, what makes this shift tricky is that, when I say that this is not completely autonomous, and what makes this shift tricky, uh, I mean to say that we delegate one task, then another, then a decision. Eventually, the system is no longer just assisting it, right? It is representing us. And an agent does not need to be very intelligent, to be very, consequential. This is what I can say, using the right word. But at the same time, if you see an enterprise setup, how agents are actually going to perform, let's say human have certain level of access provided or role provided in the system. And this also raises a question that how agents are being treated within the enterprise system. That is still not answerable completely. But if we define a boundary, and within that boundary, if we are making our agents to work, definitely that is going to save our work. Now, let's understand further, like from a real question perspective, like when AI agent makes a mistake, who is responsible? Is it developer? Is it organization? Or is it the user? So that's difficult to answer, because our legal and governance framework were designed for tools and not for representatives. And this question becomes urgent because agentic systems scale. A single agent can take thousands of actions faster than any humans. Small error propagate quickly, and undoing actions is often much harder than preventing them. Now, what fundamentally changes here is that with agent, it's not only autonomy, but it's also tempo. Decision moves from human time to machine time. So the tempo is very important here. This does not mean agentic AI is inherently dangerous. It, in many domains, it is actually necessary. Modern systems already operate beyond the speed and scale of the direct human control, and agent help manage that complexity. So the risk is not autonomy. This is what I feel. The risk is unexamined delegation. When authority shifts faster than accountability, then gaps appears, right? So the unexamined delegation is something I think is a risk that we have to basically examine. Now, how this connects to everything we have discussed so far, agents infer intent rather than wait for explicit instruction. They may learn from data shaped by other AI systems, and they operate in an environment where trust signals are weaker. All of that amplifies the impact of their actions. So, the changing face of AI is the emergence of non human actors inside human systems. And once AI become an actor and not only the tool, the rules have to be changed. Still, we have not decided the rule. And this implication or the implications become far more concrete when agentic systems are connected to the physical world. Now, let us look at what happens when AI leaves the screen and basically get into the physical world. And these two topics, like world models and physical AI, is something, these are still an area of research, but this is where people are also focusing. And this is something way beyond the large language models. Large language models are not good at all the things. So these world models are actually going to play a big role now, and people are actually researching and focusing into this direction. So what we have discussed so far, uh, or maybe AI lives behind a screen. This is what we have assumed. That assumption is now starting to break. The next major change in the face of AI is not primarily cognitive, it is physical. This is what we are observing. AI is beginning to interact directly with the real world, and not only through keywords and APIs, but through sensors, machines, and environments. It's not that it's not doing, but it's not very mainstream, and it is not much talked about, and also there is not much substance or not much evidence to try this in enterprise setup all the time. Very specific places it is getting used, not all the time. But now we are seeing that this is getting more into the physical side, a physical world side as well. Now, when we talk about physical AI, we are not referring only to the humanoid robots. It's one part, but it's not the only part. We are talking about intelligence embedded into factories, hospitals, vehicles, infrastructure, and homes. And these are AI systems that perceive the world, reason about it, and take actions within it. This is where world models become critical. A world model is an internal representation of how physical world behaves. It allows an AI system to simulate outcomes before acting. In simple terms, it let us, or maybe it lets the system ask, if I do this, what is likely to happen next? What makes this viable today is the convergence of learning, simulation, and real-time sensing. AI system can now learn from data, test actions in simulated environments, and adapt continuously based on real-world feedback. Now, language model predicts text that we know, but world models predicts consequence. That distinction matters enormously when actions affect people and safety and infrastructure. So in real world model is something that can solve a lot of problem, and I think the academia industry is also started focusing on that direction. In fact, in the research area, world model is a hot topic these days as well. Now understand like this. Imagine an AI-driven system operating in a warehouse. A language model can describe the warehouse accurately. Maybe you can do other stuffs through the language model as well. A world model understands gravity, momentum, friction, and physical constraint. It knows that executing a correct instruction at the wrong speed can still cause damage. Now connect this back to the agentic AI. So an agent equipped with a world model is not only just executing the task, it is now operating inside a physical reality. Errors are no longer only for the incorrect outputs. They become physical incidents. And in physical system, uncertainty is no longer abstract. It has mass, speed, and momentum, if you think from that perspective, right? And this amplifies everything we discussed earlier. Intent interface becomes more risky when actions are physical. Model collapse matters when system learn primarily from the simulated world. And trust becomes more critical when machine diagnose, move, or intervene. And this is not a distant future. If you see, we are already seeing this in autonomous system, industrial automation, industrial automation, or maybe in medical devices and smart manufacture. In many cases, this system works remarkably well. And the real shift is that once AI enters into physical world, slowly it is becoming, trying to introduce into the physical world. Still a long way to go. But once this real shift happens, then irreversibility will disappear, or irreversibility will appear, and you cannot roll back a physical action the way you roll back software. So it's very difficult then, and that fundamentally raises the stakes. So when intelligence is embedded into the physical world, governance becomes part of the system design, not afterthought. So the changing face of AI is not just the software or the smarter software, it is the intelligence embedded into the fabric of the real world, and that demands a different level of responsibility. So if AI can infer intent, learn from itself, act on our behalf, and operate in physical world, the final question we must ask is this: what remains uniquely human? So, $1 million question. But again, we can try to address it in our own way, but something is still debatable, and we need to basically have our society discuss on all those. So now I'm going to have my last slide. What must humans refuse to outsource? And I will not spend much time here because there is Q&A, but judgment, responsibility, empathy with friction, meaning making, and morals. This is self-explanatory. That we should be basically understanding that in these areas we should keep a scope for human judgment, and we should not directly hand it over to AI. And I also want to add with this context that the future of AI will not be determined only by the model size, the compute, or the data. It will be shaped by the choices we make about where to place authority, how to maintain human oversight, and when to slow down rather than scale. So, the changing face of AI is not only about smarter machines, it is about clear human intent. And that's why this particular slide is very important. And the real questions for all of us is not how powerful AI become, it is how deliberately we choose to use it. Thank you so much for listening to me. I'm open for Q&A now.
Thanks, Amit. These were some amazing insights that you just presented to us. And you have clearly articulated that how AI is fundamentally evolving from experimental and generative use cases to agentic, autonomous, and cloud native systems that operate in real enterprise environments. And your perspectives have helped us bring clarity on what this next phase of AI is truly demanding, from production grade architectures and responsible deployment to the mindset and models that are forthcoming. So now, as we've received some excellent questions from the audience, we'll take a few of them. You'll also find them in the questions panel for your
Sure.
reference. I'll read
Let,
it
let
out.
me check. Sure,
Yeah,
let me check it.
I'll read it out for you. So the first question is that what signals should leaders watch for to know when their organization is ready to move towards agentic AI?
See, this is not about like indication or signal to move towards agentic AI. See, ultimately, the language model that you were talking about, and I'm sure that in your organization also you must have tried large language model or any language model. See, when we talk about agentic AI, we have to see, do we have certain kind of infra ready for us? When I say infra ready for us, I mean to say that do we have a infra that can execute language model as a tool or not? Now, when I say language model as a tool, there are different way to assess it. One is a large language model, definitely, and one is small language model or domain specific model. You do not want to run your agentic system on a very large model. uh, Practically, for your task or for a specific task, I don't think this is a right approach. So we have to see whether the domain specific models, small models or quantized model are in place or not. But you know, you have to try, you have to test some of the cases within your organization, see the limitations, in which domain you are operating. So the answer is not very straightforward. What I can suggest that you try with some orchestrator. There are a lot of orchestrator available. Try to see whether you can utilize some language model or some tools within that orchestrator, and try to basically solve some of your business problem that may eventually convert into ROI. So, but yeah, to start with, do not wait for signals, because you're not going to deploy it in production unless it is well proven or evident based. So let's try to basically do some sort of prototypes internally and try to possibly address some of your internal a problem that your organization faces. Let's say, for an example, SharePoint related. You might have a lot of data within your organization, and you want to basically apply some of the agentic AI solutions. So internally, the risk is quite less compared to the customer related data. So you can have a controlled environment. You can try on some specific use cases and try to see how it is behaving, and according to that, this can create a success story or use case for your customer when you interact with them. So let's not wait for a signal. I would suggest, try to create some sort of prototype, upskill your associate, because when we talk about agentic AI, it's not that you need a data scientist to work on agentic AI. You actually need people, those who understand software engineering. And in fact, I was talking somewhere, and I was actually saying this, that software engineering is now again back to fashion. And between, there was a fashion for data science or data scientists. People were talking about data scientists all the time. Now, because of agentic AI, we'll see that the system architects or software engineers are again going to back into the fashion, because they know how to integrate the system and they know how to write the code. They just need to use the tool. They just need to access the APIs. Similarly, it's one step ahead of the generative AI that we are using. Now, generative AI tool is going to be part of agentic AI system as one of the tools. So try, test it, and then identify your correct ROI and use cases, evidence based, I would say, but do not directly jump on production. Yeah, for sure.
Yeah, right. So moving forward to the next question, as it's understood that AI is here to help us and not to take anybody's position. However, thinking AI as robust and autonomous for every field and application seems unrealistic. So shouldn't industry evolve maturely with respect to areas for AI?
Definitely, it should evolve, and it's not that autonomous system is going to take your job. As I just discussed, agentic AI. So people thought that agentic AI will take up your job, but agentic AI is not going to create or not going to do system integration for you. You need a domain expert or a business understanding to create agents for your systems. As I mentioned that although agentic AI is going to solve a lot of problem for you, but still you need system engineers and system integrators, as well as architects to architect the system. And definitely there is so the nature of a job will definitely change, but it's not going to take everything from human. Definitely the one, or definitely people will resist for the one that we discussed on the last slide. But even technically also, this is, I feel that this may shift the job or displace the job. The nature of the job or the role may change, but definitely there is a demand. In fact, if you see in your organization, previously the AI work or the data science work might be reserved for only data scientists, AI engineers, or AI researchers. Now in your organization, developers are also working on creating AI use cases. How it is possible? Because you are getting libraries, you are getting APIs. and you are basically using it to create solutions. So definitely, you know, it's, I would say, as you mentioned, I agree with you, and definitely there should be something that industry evolve from here. But still, there is time that we get into completely autonomous. Even if we get theoretically or hypothetically for now, still there's an option, at least in my understanding.
Right, Amit. And that, of course, justifies the part that we really need to be industry specific with the involvement of AI in this coming world. Then moving forward to the next question, Dr. Dipankar is asking that, as you just said, that the AI characteristics have changed a lot. What can a blind, deaf, orthopedically challenged, and autism affected person can benefit from in their struggles to remain economically self sufficient in modern day AI?
See, I think as AI evolves further, um, I let me just what can a blind, deaf, orthopedically challenged, and autism affected? Okay, I think for an example, there are glasses coming now for blind person, or maybe for deaf person as well. I was actually going through some of the article where it helps you to understand your environment. Based utilizing AI based or AI powered classes. So I think there are tools coming out, but still, in the physical world, I'm talking about, like if somebody is into the physical environment, and I think that part is still evolving, but definitely this is going to help them to understand the world around them. Autism affected person, I think definitely, I'm not expert into this field, but from an AI perspective, there are a lot of solution coming that can support autism. In fact, the simplest one is related to the agents or the chatbot specialized in autism related Q&A, just to boost the confidence of the person and just to help them guide. I'm not sure whether this is medically correct to say this or not, but there are chatbots that is actually helping autism person to gain the confidence into that area. But yeah, this field is something that is not very explored to me, so I cannot provide a very in-depth understanding from a medical standpoint. But from an AI standpoint, definitely things are, AI is making things easier, even in physical world as well as into the virtual setup.
Right, Amit. So, which makes us move forward to the next question, that is, what governance mechanisms are critical when deploying agentic AI that can act across systems and workflows?
Again, this is something very debatable point. I think while I was discussing, I mentioned about it. uh, Access control and etc needs to be there, how the data is going to get access. Let's say if your agent is accessing some external website and utilizing the data from there, or basically doing some actions based upon that particular information, how you're going to take control of it. So there is a lot of unexplored, not unexplored, I would say, or maybe the spot that is not yet explored, or people are still working on it. So to answer your question, it depends on the kind of use cases you are trying to actually solve. But what I can suggest, work on a controlled environment, work within a controlled environment, and then execute the task according to it. So I think while I was in discussion within some of the slides, I was discussing about the similar thing, where human had, let's say for an example, in many of the organization, you can access GitHub, right? Or somebody can access GitHub, and maybe few of them cannot access GitHub because of access control, or maybe the role defined to that particular person. So can we basically define such kind of access level to agents or not? So I think there are a lot of questions like this that we need to understand. In fact, our personal laptop, office laptop, if we talk about the office laptop, in office laptop, many of you or many of us cannot, install something from our own side. We need to go to our admin team and ask for the installation. So we also have to think from that direction, and that is still debatable. That's why I said that the controlled environment or a control system is required to execute such task, and this the governance mechanism is something very debatable. Depends on the kind of problem that you are addressing. Not very straightforward answer. Let me be very honest with you.
Yeah, absolutely, Amit. So
So I
now
think I can take
we can
just
take
go to
the last two questions.
okay, okay.
Yeah. So Rahul is asking that when designing cloud native AI architectures, what trade offs do leaders often underestimate? Cost, latency, or security?
Depends on which kind, like what kind of organization you are operating in. Every organization has their own way of, uh, their own strategy with respect to cloud. uh, and the kind of cloud system they are actually operating with. So again, very very contextual. But definitely, if you ask organization, they are very much into the security and cost for sure. Everybody wants to control cost, and everybody wants to have their data and their environment secured. Latency is something, if you see, even in different cloud providers, or or maybe even if you talk about native AI, cloud native AI architecture, or APIs, specifically if you talk about APIs, it is not something that cloud can make your system faster or slower, whether you use any of the cloud system. The kind of AI services you are using, or where you are interacting with. For an example, if your AI architecture is basically dealing with streamed videos, high definition videos, definitely there will be latency. It's not that there will not be a latency, but how you are tackling it, minimizing it, that's your engineering problem. That is not something, a cloud, or cloud based system can address. It is something that you have to think about. But definitely, if you think the trade-off point, definitely there will be latency. How can you minimize the cost? Let's say if you want to detect some object in a live streaming video, maybe you do not want to have your the detection mechanism or identification mechanism on all the frames. You want to minimize the frames based upon the kind of use cases you are dealing with. And definitely security is something that everybody is looking for. So you have to have all of these together, but depends on the kind of problem you are addressing. Security is something that you must look for. Cost is subjective, based depends on your organization. Latency is something that you have to deal with because you are going to work into the production system. So lower the latency, it's better for customer delight and execute something in the critical system.
Yes. Right, Amit. And let's take the last question for the session. That what are the most common mistakes that enterprises make when trying to operationalize AI beyond experimentation?
Hmm. I can provide a very controversial answer, but you need to have a leader that actually understands AI and some business area. See, I can answer it technically, like what, but in my opinion, uh, the leader is very important here, because he is the one, or she is the one, who is taking decision to go beyond experimentation. uh, Leaders should not get influenced by their team all the time. They should thoroughly understand the kind of system or solution the team has developed, and what can go wrong in real world. So this is something that I can, as I mentioned, I can provide some of the repetitive answer, but this is what I feel. Enterprise should have a leader that understands the implications related to AI, and also how systems behave in real world, and not always relying on their team because they are pushing it to make it on production.
Yes.
Sorry, I know this bit controversial, but I just wanted to have from this perspective. Yeah.
No, we are glad that we got that perspective as the answer from you. And definitely, with this, we wrap up the session as well, as this session leaves us with so much to reflect on. Not just the frameworks and approaches discussed, but the broader shift underway in how enterprises design, build, and scale AI systems as they move into an agentic, autonomous, and production grade future. So, with that, we wrap up this highly insightful session on the changing face of artificial intelligence. Thank you so much, Amit, for your time and valuable perspectives. It was really an absolute pleasure hosting you and hearing from your expertise.
Thank you so much, Krishi, and thanks for having this opportunity to speak to a lot of people. Thank you so much.
Likewise, Amit. And a heartfelt thanks as well to all our wonderful participants for your engagement and thoughtful questions, which made today's session a great success. This session has been recorded and the recording will soon be available on techgig.com. Thank you everyone for joining us. We look forward to seeing you again in our upcoming sessions. Thank you, Amit, for joining. Have a great
Thanks.
day.
Bye-bye. Bye-bye.
Take care. Bye-bye.